We're going to walk through the mileage activity worksheet for sample 10. Question 1 says to check the conditions. Your textbook asks us to check to see what kind of variable we have. And in this case, mileage is a quantitative variable. We do have a random sample because all 10 of the samples were randomly selected by Minitab. We need to check to see if we have a large sample or if it's reasonable to assume normality. And in this case, n is equal to 40, so we have a large sample. If we didn't have a large sample, then we would need to look at some graphs of the data to make sure we don't have a lot of skewness or outliers. And we could also look at a normal probability plot to see if all the points fall close to a line. And some textbooks will ask us to check to see whether sigma is unknown. Sigma is almost always unknown. If you did know sigma, then you would use z instead of t. But in this case, although I knew sigma because I had the entire population data set, what I gave you was just the sample data, and I gave you the statistics based on the samples. So you were given S, the sample standard deviation, not sigma. Question 2 says, use your table to figure out what T star would be for 95% confidence for 30 degrees of freedom. If N is 40, then your degrees of freedom would technically be 39, but that's not in your table. You could use 40, and that would be pretty close to what you need. But a more conservative approach, if all you have is the table, would be to use 30, because that will give you a slightly larger T than what you actually have to have. Okay, so now we're going to estimate the mean mileage with a 95% confidence interval. And I use technology to get the critical value T for 39 degrees of freedom. And I will quickly show you how you could do that. If you go into Excel and then click on F sub x, and then you select statistical for your category. You go down to T. You want T dot INV for inverse. And what you're going to put in is the probability is the area under the curve to the left of the T that you want. So it's set up a lot like your normal table is. And for 95% confidence, if you draw out the picture, you'll have 95% in the middle, and you'll have 2.5% in each of the tails. So you would have 0.975 to the left of the T that you want. So I'm going to put in 0.975, and degrees of freedom would be 39. And at 2.022691, I can carry that out as many places as I want. I only took it out to 3 places because that matches up with your T table. There are also some online applets that you could use. And here's one of them. This is Statistics Kingdom T Distribution Calculator. So I've got 39 degrees of freedom. And here it will give me either a T value or a probability depending on what I tell it. So I've got to tell it what I'm giving it. I'm going to give it the probability, which is, you can see the less than or equal to there. I'm giving it the area to the left of the T that I want. So again, I'm going to put in 0.975. And if I hit calculate, right here, it will say X is, and you can see we get the same thing that we got using Excel. So about 2.023. And you can also use this applet to find p-values if you want. And in that case, you would give the calculator the value of t, your test statistic, and then it would give you the area to the left, and you would just have to subtract it from 1. If you're doing a two-tailed test, you'd have to double that. Okay, so back to the worksheet. For sample 10, we're going to need X bar and S. So if we go under the descriptive statistics for sample 10, look in the mean column. This is my X bar. That's 24.625. The standard deviation is 5.601. So I plug in those values along with my T critical value of 2.023, and I get 24.625 plus or minus 1.796. I subtract and add to get the endpoints, and here is my 95% confidence interval. Number 4, interpret the confidence interval. We are 95% confident that the true mean mileage for the population of cars is between 22.8334 and 26.4166 miles per gallon. All right, what is the midpoint of the confidence interval? The midpoint is the estimate, the point estimate. In this case, that's my X bar, 24.625. That will be in the middle. If I didn't know what X bar was, but I had the interval, all I would have to do would be to average the endpoints. So for example, if my interval happened to be 20 to 30, if I average the endpoints, I get 25, and I would know that that had been the X bar used to construct the confidence interval. To get the width of the confidence interval, I can subtract the lower endpoint from the upper endpoint to get 3.5832, or I could just take the margin of error and double it. What is the margin of error? Well, the margin of error is the plus or minus part. So we computed that right here. It was 1.7916. And if I didn't have all of this information, all the numbers that were plugged into the formula, but I did have the interval, to get the margin of error, I could take the width, I could subtract the lower endpoint from the upper endpoint and get the width, and then I could take that and divide it by 2, and that would give me the margin of error. What would happen to the width of the confidence interval if we increase the confidence level? Well, if we want to be more confident, we've got to cover more numbers, so the width would increase. What would happen to the width of the confidence interval if we increase the sample size? Well, sample size is in the denominator here. Well, it's under the square root and the denominator here in our margin of error. So if we increase the sample size, the margin of error should get smaller, which would make the width also smaller, so it would decrease. What would happen to the midpoint of the confidence interval if we increase the confidence level? It wouldn't change. If we increase the sample size, the midpoint would stay the same. I suppose you could argue that if you increase the sample size, technically you're taking a different sample, maybe you'd get a slightly different estimate, but basically what I'm saying is if we assume X bar is the same and we just change that sample size, what does it do? Well, it doesn't change the center. And I also would like to show you how you could find what you want in Minitab. Minitab, if you go under Stat, Basic Statistics, One Sample T, and then if you had the data, you could say, well, it's in a column, But you can tell it, well, I've got summarized data. So my sample size here was 40. The sample mean for sample 10 was 24.625. And the standard deviation was 5.601. And if I go under options, it's already got a confidence level of 95%. So I'm going to leave that alone. And you can see my confidence interval goes from 22.834 to 26.416, which is roughly what we got here, working out the problem by hand. I could also do the same thing on the graphing calculator. So if I go under stat, and then tests, arrow down to T interval, I've got to tell it if I have the data, the raw data, or statistics. In this case, I've got statistics. If I had data, I would do this, and then I would put the data in the first column of the little spreadsheet-like area that we have in the calculator. But here, we're going to say we've got summary statistics already. So X bar, again, was 24.625. And standard deviation was 5.601. N was 40. Confidence level, it wants as a decimal. So for 95%, just leave it at 0.95. Go down to calculate, hit enter. And we get 22.834 to 26.416. Now, you were given a handout that had this information. So here's the population information that I did not give you. And most of the time in practice, of course, you would not have access to population data, because if you did, you would not be doing confidence intervals. So there were actually 1,076 mileage values in the population. The true mean is 24.823. And if you want to check your work on your confidence intervals, here are the 95% confidence intervals for all 10 samples. All these are 95% confidence intervals for the true mean mu. Each one is based on a different random sample. And then here is a graph showing all of those intervals. You can see there's a reference line at the true mean mu of 24.823. And it looks like all of the intervals capture the true value except possibly the one for sample 3. Let's see, 24.823. If I look at sample 3 just misses